Good day, everyone. We are going to look at object oriented programming. In today's session, we have the following objectives. On that is understanding the history and principle of object oriented programming, exploring object oriented analysis and object oriented design, and then we are going to look at the applications related to this OOA and OOD. Students are also going to gain insight into the concepts like encapsulation, polymorphism, inheritance, and abstraction as the four basic principles of OOP. We are also going to learn a robust and reusable software design so that at the end of this module, students out there will have the ability to design and analyze object-oriented system. Will also be proficient in applying object-oriented principles in the fields of programming, improve the understanding of reusable and manipulations of code design. That is familiarity with modeling tools and then unified modeling language diagrams. Now the introduction. Object-oriented programming is the programming paradigm that organizes software design around objects rather than the usual functions or logic. These objects represent real-world entities and are used to model and solve problems in a structured and reusable manner. Having this, let's look at the historical evolution of this object-oriented programming. The object-oriented programming has evolved significantly since its inception, with notable milestones shaping its development. And it began in the 1960s. The first object-oriented programming language, which is named Simula, was developed in 1967 by a researcher at the Norwegian Computing Center. Simula introduced foundational object-oriented concepts such as classes and objects. In 1970s, that is in the early 1970s, Alan Kay and his research team at Xerox PARC developed Smalltalk system. That is a language that further advances object-oriented programming principle. Smalltalk emphasized a uniform object model and introduced features like message passing between object and object. We know in normal sense, we don't just usually pass message to nowhere. We pass message from object to object. This is all what our object-oriented programming is dealing with. In 1980s, then the integration of object-oriented concept come into existing programming languages, notably Bjarne Stroustrup developed C++, which added object-oriented features to the C language, facilitating broader commercial adoptions of object-oriented programming. And then coming to 1990s, the 1990s marks the proliferation of OOP with the introduction of language like Java, which was designed with object-oriented principle at its core. Java platforms, independence, and robust libraries contribute to this widespread use of object-oriented programming. 2000s and beyond, we have dynamic languages such as Ruby, such as Python. They all came together and embraced these object-oriented features, making object-oriented programming more accessible to all developers. Here we have object-oriented analysis, and our object-oriented analysis is the procedure or the key procedure of identifying software engineering requirements and developing software specification in terms of software systems object models. We know in everything you're doing, you must have phases, you must have cycles. So our object-oriented analysis is here with the procedure to help us identify these software engineering requirements in developing these software specifications. The main differences between object-oriented analysis and other forms of analysis is that object-oriented approach, right? Object-oriented approach, the requirements are to organize around the object. That is the main difference. The object-oriented analysis is just around the object. It will go nowhere. All it's been doing just around the object, study the behaviors, study the functions of that very object. That is the main difference of these object-oriented analysis and other form of analysis. If you were to ask, you can just state it that the main is that the object-oriented approach requirements are organized around object. That's as simple as this. So we have the primary tasks that this object-oriented programming that need to perform. And what are the tasks? We have, first of all, the object-oriented analysis need to identify the object first. What object are you going to work around? Right? You specify this object, then you organize the object by creating a model diagram. So in whatever things you are doing, if you have identified that object, you should be able to develop that program by having a model diagram. No matter what, try to create a pictorial representation of that very object. We are going to look at these models later in these sessions or in the next sessions. We are going to be talking about them. So also defining the internal of this object or the attribute related to that object. What are the features? What are the behaviors related to this particular object is very, very paramount. It should not be left behind, both internal and external. You should clearly define it as an object-oriented analyst. So also you define the behavior, which we have already said it earlier. That is the actions. What are the actions this particular object is going to perform? At what state? At what level? So all these need to be put into consideration. Describing, that is what? That is the fifth primary task of object-oriented analysis, is going to describe how this object interacts with other objects. So it's also very important for you to take note of this. So after you are done with the object-oriented analysis phase, so all you need to do now is to move to what? To object-oriented design. And in your object-oriented design, you know this involves implementation. There's implementation of the conceptual models you produce during what? Object-oriented analysis. You have produced something at what? At the object-oriented analysis. So what you're going to do now is the what? Is the implementation of these conceptual models you have developed. So you have an idea, you develop the conceptuality of that. So what you are going to do now is the design. So the concept in this analysis model, which are technological independent, are going to be mapped onto implementation classes. So you are going to look at the constraints here. Constraints are to identify what? You are going to identify the interfaces at each design, resulting in a model for what? For solution to its destination. So each object you have taken, you have the model, you have the concept, right? So you are going to what? Concentrate and see the interfaces now. So this is what you are going to be looking at. And at this, the implementation detail generally is going to what? Include the following. So because we have said it earlier in the beginning of this class, that whatever things you're doing must include phases, must include stages, right? So here, The implementation details according to this object-oriented design must include the following phases. And these phases are what? Restructuring the classes data. That is the classes you have at the concept level. You are going to see how you can be able to restructure the class if necessary. It's not compulsory. If you are okay with the area at the analysis phase, you don't have any problem here at the what? At the design. But you need to take the implementation method, which is the second implementation detail that you need to put into consideration. That is, you are going to look the internal data structure and algorithm. Whenever you are trying to program, the internal method, the internal structure is always important because that is where everything is taking place in the programming. So you take note of the implementation during that, the internal structure, how does the object interact with each other at the internal level. So coming down to the what? To the algorithms. What are the processes in which you are going to follow in implementing this thing? So what are the controls? What are the controls measures you are going to what? Deploy or implement during this implementation? And then the association. The association is very important. This is what brings about relational diagram. So because without the association, your program will not, or your object cannot be able to interact with each other. So the association here is very, very important. You need to what? Take good care of it. You need to give it maximum attention in dealing with that stuff of programming. So I believe we have an idea of this. We don't have any matching problem. We are quite understanding what we are doing. So remember, we are dealing with object-oriented programming. That's what brings about looking at the evolution of this object-oriented programming. We look at the analysis, and then we are now done with the design. So let's look at the main concept of object-oriented programming itself, and then looking at the object-oriented programming, we know this is the most important features of object-oriented programming in general, and then it's a software engineering approach, or we can say it is a programming paradigm that one must adhere to once is a programmer. Once he's a programmer, he need to have idea of how this object-oriented programming works, and we say this is a programming paradigm that surrounds itself on the object, that is having both data and method. And the main aims of object-oriented programming is to incorporate the advances of modularity and the reusability of your code. So that is the main objectives of object-oriented programming, or the main aim of object-oriented programming is to make sure that you have code reusability and modularity. So everything in object-oriented programming surrounds about objects, which are usually our instances of classes. We have classes. We have been doing Java class declarations and so on. So everything about classes is about object. We have already know that. So these are usual instances of classes are used in order to interact with one another, in order to design applications and computer program. So that's all about object-oriented programming. Aim of this is to incorporate the advantage of modularity and then code reusability. If you cannot be able to reuse your code, it means that your code is useless. And then it allows us to design applications and then computer program. Let's look at these important features of object-oriented programming that we are having. We have outlined almost 5 key features of this or important of these features of object-oriented programming, which are almost in terms of bottom-up approach in programming design, right? So I believe you are going to do that in your software engineering course. So one of the features is that the programs are organized around the object, and they are being grouped into classes, which we have been explaining. Everything about object-oriented programming is surrounded itself around the object, and these are grouped into classes. And the second feature is that this OOP focuses on data with method in order to cooperate upon objects data. Are we together? It operates itself upon this data object. Remember, everything that we are doing, we are on object. This object have properties, right? That is the features. So how this object behaves now is the method. Are we together? Is the method. So the third one here is the what? These object-oriented features are what? To interact between object through what? Through the functions. So we have functions that we are going to interact between this object through them. Like, say if you have uh, an object or a class that you have declared its functions and methods. So these functions, they are the one we use to interact with the object. So every time that we want to pass any output or any declaration, we are doing it certainly on these very functions. So that is the third features of object-oriented programming, is to interact between object through these functions. And the fourth one is what? The reusability of design. Reusability of design through the creation of new classes by adding features to existing classes. And this, you're going to get this thing more clearer if we are dealing with inheritance. That's how you've been able to have a single class, and then everything around that class will be able to pick up by another new class that is being declared newly. So that is what they are saying here. So this is what we have as our features of this programming, object-oriented programming. Though we have we have examples of these object-oriented programming languages, and these include the C, C++, C, Java, then those Smalltalk. We have just a lot of them: Python, Ruby, PHP. They are all object-oriented programming. They allow modularity and their reusability. Why? If we are to ask, why is it that these object-oriented programming languages are being called object-oriented programming? Is because they allowed modularity and reusability of their codes, right? This is the only thing why they are called object-oriented programming. Are we together, please? So having that object-oriented programming, so we have what we call principles of object-oriented programming. Though these principles varies in terms of scholars, here we have outlined, or we have considered as the foundational principles of object-oriented programming, which we have encapsulation, we have inheritance, we have polymorphism, and we have abstraction as the foundational what? Concept or principle of object-oriented programming. In some scholars, they are having from the classes, the object, the just a lot of them from classes, object, and what have you. They have it as what? Up to 5 or 7 of it as their what? Principle of object-oriented program. But for the purpose of this class, we have outlined 4 foundational principles. So don't get confused. If you were asked foundational principles, just give that 4. If you were asked principles of object-oriented programming, so you need to give everything you knew about object-oriented programming principles. You need to get that right. So the principles here, we are going to look at encapsulation, right? We are going to look at encapsulation. So encapsulation here is a way or a method in which you are going to combine both the attribute and the method together within a single class. Both the attribute, that is the features, and then the methods into a single class. That is now accessing this data is going to be what restricted to what through control interface, right? Accessing this is going to be what restricted to control interfaces. That is, you are with the internal detail of a class can be hidden from the outside. So it is what? It is permit that the element of the class to be accessed from the outside only through the interface provided by the class. So here is where you are going to have both the public and the local access, right? So and this brings about what we call data hiding. And our data hiding are typically classes that are designed such that its data, that is to say attribute, can be accessed only by its class, not by another class. So only the class that are what designed to access those attributes or those methods are going to be able to access it. And it insulated, like it's just a form of a capsule, like we can take it. So nobody can be able to access the inside of this capsule unless what the owner of the capsule, right? It's been protected, it's been restricted. So this process of insulating an object data is called data hiding or information hiding. This is very, very essential. Please, you need to get it, right? The process of insulating object is called what? Or object data is called what? It's called data hiding or information hiding or data restriction or information restriction, as simple as this. No more, no less. So let's say, for instance, you are going to have a cycle. So the data hiding can be incorporated by making the attribute invisible from outside the class and adding two more methods onto the class for accessing class data. So you are going to do that only by using what? You get value, which is have what? Methods that are going to assign the values, right? And we also have methods that is going to what? Retrieve values, which is called get values. So we have set values, which you assign the values to them. We also have set values, get values, which you use to what? To retrieve the value from the class. So we are going to look, next is the inheritance as the second principle or concept of object-oriented programming. And these are mechanism where you have a child or a class, and that you have two or more classes. The first class will be probably going to be called superclass, which is the parent class. And we have another class called child class, which is going to be the child class is going to be the subclass, right? So the child is called the what? The subclass. So this is going to what? Acquired the properties and behavior. That is what the child is going to acquire or inherit the properties and method of the parent class. Are you together? That's just a form of our like normal tradition where if someone dies, someone can inherit, or someone can inherit the futures of his parents, right? Someone can inherit the futures of his grandchild, and so on and so forth. So this is very, very important in the field of programming, programming concept. So usually the child, usually he's the one that is going to inherit from the father, all right, from the parents. And the parents are called superclass, the childs are called subclass. So in this regard, we have uh, 4 or 5 basic of types of inheritance. And then we have what we call single inheritance. So in single inheritance, it means that uh, a subclass, that is the child class, is going to inherit directly from the what? From the parent. That is 1v1, right? Inheritance. So in multiple inheritance, we have a child or two child classes that are going to inherit from what? From a single parent class. That's from the single super class. That's the multiple inheritance. So we also have multi-level inheritance, and in multi-level inheritance, a class must have number of subclasses, each of which are going to have subsequent subclasses containing a number of levels. So these classes are all going to inherit from what? From each other. Like say example, you have in a household, you have a grandparent, you have a parent, and you have a child. So these child classes might be two classes. So again, this child can inherit from the parent class and can also inherit from the what? Grandparent class. That is what multi-level class is all about. So in hierarchical inheritance, a class must have a number of subclasses, each of which may have subsequent subclasses containing a number of levels, so as to form a tree structure. Right? We know a tree structure mostly happen if you are having XML, right? So these are going to be in a what? Multi-level. So we have hybrid inheritance, and this hybrid inheritance, a simple way to put it, is a combination of two or more of these inheritance type. Like you combine single inheritance and multiple inheritance together, we combine here a single inheritance with multi-level or hierarchical. So if you can be able to combine these types of inheritance in one place, it means you are having a hybrid inheritance form. So this is the way how we put our inheritance, just as the way we put our encapsulation. The next we are going to look is, we are going to look at encapsulation. We are going to look polymorphism. We have looked at encapsulation. In polymorphism, we can say polymorphism must have the ability of an object to take on multiple form. And this polymorphism was originally a Greek word that means the ability to take multiple forms in an object-oriented paradigm. Polymorphism implies using operations in different ways. Thus, you have poly means one, then morphism means many. So that's the ability of using this single method in many forms. So that's what is depending upon instances you are operating upon. And then this polymorphism allows objects with different internal structure to have a common external interfaces. Are we together? We need to get this right. The internal structure is going to have within different internal structures to have common external interface. You have internal A, internal B, internal C, and then the external interface can be one single interfaces. That is the main aim of what? Polymorphism here. Particularly, it is very effective, particularly while implementing inheritance. So you see how the concept now interswitching between one another. So we have an instances here based on our lecture material. We consider two classes, that is cycle and square, each with a method called find the area. So you see both the cycle and the square has what we call area, right, as a method. So though the name and purposes of this method in the classes are the same. Like find the area, you did not mention which area, right? So the internal implementation, that is the procedure of calculating the area, differs, isn't it? So both have their different formulas. So for each classes, when an object class cycles involve its find area method, the operation of finding the area of that very cycle without any conflicts with the find area method of the square class. So each of which you have find area find as an external structure now. You have internal structure with their what? Each with its own method that is having their different formulas as the internal structure. But in the external structure, you are having what? One single method called find area. So this is what is as simple as this. we can put it this way. So we have what we call abstraction. In a simple way to put this, abstraction is just hiding complex implementation details and exposing only the essential features of object in a system. This is very, very, very important, let me tell you. You are going to hide your system, you are going to hide your idea from those people that are doing what they call still writing. Those people that want to copy your idea, you can be able to hide all these essential features of object, then sorry, all the complex implementation, and allow only the essential one. This is just just the way we are doing. Let me give this instance. You all did web designs, right? And during this web application development, you had you have opportunity to work with PHP, right? Anything you type within this, or you code within this PHP, right? During hosting, like if the system is live, we know one can go to the browser and look for source. So from that source, you can be able to copy all what you have developed. But you know one thing, because that PHP having that sense of abstraction while you're working with it, so whatever content within that PHP is going to convert it automatically into HTML, so that that very particular person cannot be able to see your PHP code. He can only see the essential of that HTML code. So you see now, this abstraction is very, very important in hiding these complex instructions and allow only the what? The essential features. So we have given examples of this, and then so in this regard, we also have what we call state and then state transition. So when we talk about state in abstraction, we say this is an abstraction given by the value of attribute that the object has at a particular time period. That is, at what very position, at what very level that object is at that moment. So this is it is a situation occurring for a finite time period. In a lifetime of an object, every object has its own state. At present, I'm at this state of delivering these lectures. I'm at this state of pronouncing state, right? I'm at this state of raising my hand. I'm at this stage of what? Opening my mouth to say something on this very particular object. So in which this object, this state fulfills certain condition, performing certain activities, or wait for a certain event to occur. So that is for the state. Then where we have part of this state, we have parts of the state, the component, right, of this state. One, we have name of the state. So the name of the state here is the string that differentiates one state from another. A state may not have any name. Are we together? A state may not have any name. I have said something before regarding state. I'm at that state of saying it. That very particular minute of lectures may be the name of the state. Again, I am saying the same thing now. This very particular time that I'm saying the state might be the name of another state. So state cannot have the same name. Are we together? It can vary. So it can be any what at any form. So we have what we call entry and exit of a state. That is the action this state is taking place. So this is what concerning the activities you perform, or concerning the activities that very particular state perform on what? Entering and on exiting that very particular state. So at what level, at what point does that state coming in? And at what end does that state it's what exiting from the system? Are we together? So we also have what we call internal transition. That is the changes within the state that do not cause a change in the state. So if you look at this, we also have what we call substates. The substates here are what states within states and then initial, that is the initial and final state. Looking at the diagram we have on the screen here, we have initial state coming up down as what? As a waiting. While it's waiting, it's going to move to the what? To the riding, then to the state, to the final state, right? So the interval in between this initial state and the final state is called transition. And the waiting is the state of itself, the riding is the state of itself. So you see now, both are state but with different name. The difference between these states is what? The transition. Are we together? So this is all about state, right? So we need to take this very serious. Then we have what we call transition in a state. We already know our transitions is the changes in state of an object. If the object has a certain state when the events occur, so the object may perform certain activities subject to a specified condition, and the changes of that state is what we call to as transition. We have seen it in the given diagram before, this very particular diagram, right? So again, we have part of this transition. So part of this transition is the source of state, right? Is the source of state. That is the state affected by the transition, right? The transition's been affected, or the state is being affected by the change in position or the change of an event. So this is the source of the state. We have event trigger. This occurrence due to which an object in the source state undergoes the transition if the guard condition is certified. Are we together? So get the taxi, like you are waiting for a taxi, the event there is just to get a taxi. So that is an event, right? So we have guard condition. Are we together? We have guard condition. What is that guard condition? It's a Boolean expression which is going to be, which if true, it will now cause the transition to take place. If it is false, the transition will not take place. That is the guard condition. As simple as this. If you were to ask in the part of this transition, which part of the transition is responsible for a transition to take place? If it is true, it's just that condition. Are we together? So we also have action. This is an interruptible and atomic combination that occurred after the condition or after the completion of the transition. So once the completion of transition has taken place, it means the actions also have taken place. So we have the target action or the target state. It's where the state is heading to. So this is all about this state and transition. All about state and transitions. We have at the beginning of this, we've said something about object-oriented system, object-oriented design, right? So when we talk about object-oriented or object-oriented system, this we are talking about the techniques we use in visualizing our system during the application development, and any software development approach goes through these object-oriented design or object-oriented system. And this also varies, depends on the scholars, depends on the books you're reading. We might have something like requirements as a single process. We have analysis, we have design, we have implementations, and so on and so forth. But here we've embedded the requirements, that's the system requirement with the analysis. So at the analysis phase of this object-oriented, here you are going to formulate a problem. And if you formulate a problem, you are going to look at the requirement, the system requirement, and at the requirement here, you are going to identify this requirement, both the user requirement, the system requirements, all sort of requirements is going to take place during this system analysis or object-oriented analysis. And then the model is what is going to be built upon the real world. So this is why you are taking care of this. So we now going to look at the design. So the design, how are you going to what? Going to take care of the design. So at this, you are going to look at the architecture of the desired system. So most of the time, you have something like you have a waterfall design, you have spiral spring design. So you just need to what? To design your classes in these phases. So all sort of system design you need to take care of it at these very particular phases. Also, you need to consider the existing system design. The existing system, which type of design do they use? So look at it, study it, see how you can be able to rectify it. Don't say that because this system is not existing. No, the system must exist even by manual. So the manual way of dealing with that particular system you are about to design is also part of what? Part of the existing system. Are we together? So we now look at the implementation now. So how and why, where, how are you going to what? Deal with this implementation? So it is very essential how you are going to implementing the tools you are going to use in implementing this your system and what have you is very, very important. So we have structured analysis. We have looked at the structured analysis and we have looked at object-oriented analysis. What are the differences between these structured, or we can say structured analysis v object-oriented analysis? If you look at the structured analysis, its primary goals is to create a clear and detailed blueprint of the system before it's been developed, right? So while the object-oriented analysis focuses on identifying the object entities with both data, right? The data include the attribute and the method and the relationship, that is the associationship, to design a system. The main component here include what? The classes, the object, how are you going to protect your data, how are you going to inherit the features of this data. So the structured analysis approach, we can say, is the traditional approach of software development based on what we call waterfall model. The phases of these developments include, you are going to conduct feasibility study. After you have taken care of the study, you look at the requirement of the system, both the user and the system requirement. You are going to study, you are going to design the system, you implement, you now go about reviewing the system. That is the requirement of these the phases of this development. If you just know waterfall, I believe we are going to have a practical session here by where you are going to see how you can be able to design your waterfall model, and going by each phase how you can be able to do this. And then the advantages of this object-oriented analysis is that it focuses on data rather than the procedure, right? So it's also the principle of encapsulation and data hiding, which helps developers to develop systems that cannot be tempered. So it helps developers to develop a program that cannot be tempered, and also it helps developers to develop the system uh, that cannot be tempered by other parts of the system, right? We have said that. So also it allows the effectiveness of managing software complexity. So that are the advantages of the software object-oriented analysis. Then the disadvantage is that the functionality is restricted within object only. So secondly, it cannot be identified which object will generate an optimal system design. That is the main disadvantage of this OOA. So in this OOA again, object-oriented models do not easily show the communication between objects in a system. So that is the disadvantages of object-oriented design. So we talked about the structured object. What we are talking about, the structured analysis, and in the structured analysis, the advantage is that it follows a top-down approach. contrast to what bottom up, and it's also based it is based upon functionality, and the overall purpose is to identify it's to identify the functional decomposition. And the last one is they are written simply in an English way, and the disadvantage is it does not support reusability of code, unlike object-oriented analysis. Are you together? Object-oriented analysis. So it is initial cost constructions. It is high. So these are the disadvantages of this system. So with this, we have come to the end of this. So before we wrap up this, remember we are dealing with object-oriented programming, where we look at the evolution of object-oriented programming, from what from inception to the early 2000s and beyond. We also look at object-oriented analysis. We look at the task that is concentrating on the primary task in object-oriented analysis. And then we look at the object-oriented design. We look at the difference of object-oriented design, which we just conclude giving the differences. We look at the object-oriented programming concept. We look at the principles. We look at the examples. And then we look at the stage under abstractions, and also under principles we look at the types of inheritance. We look at the states and then the transitions. We look at the parts of transitions. We look at the object-oriented system and so on. So in conclusion, we know that this object-oriented analysis is a method of analyzing of analysis that examines requirement from the perspective of classes and objects found in the vocabulary of a problem solving domain. So keep practicing, keep learning, keep asking questions. If there is any area you did not get it right, you don't hesitate to knock at our door. We are always you are always welcome. We are always available for you guys. Thank you for being part of this class. Remain blessed.